Well, welcome everyone. Thank you so much for coming. Really tons of stuff going on here, so feel very humbled that people decided to show up to hear about, pipeline development. So what I wanted to talk about today, well, first, just a quick introduction. I work for Enigma Technologies. We build small business data products, so if you're interested in small business data at all, please come talk to me. We have a lot to talk about. And this is also kind of co-hosted by Dagster Labs, which builds a fantastic workflow product, which we use and we'll be talking about today. So I guess the main thing that I wanted to talk about today is really how development happens and good development and developer velocity. And I think if we think about the application of kind of DevOps, practices and principles to data engineering, it's really important that we get the isolation right. And I think when any kind of development that we're doing these days involves some kind of isolation. And when we think about kind of the traditional software development world, we're using tools like Git all the time, and it's kind of like our bread and butter. We also have this concept of environment staging, ephemeral environments, and things like that. But at least what I found in my personal experience in kind of talking to others is that those things don't kind of translate super well into the data engineering landscape. So I think where we usually start out when we want to do something a little bit more than just having one kind of prod data pipeline is we kind of revert to this classic pattern of having a dev environment, a stage environment, a production environment, and we kind of try and move between those. And this is certainly better than trying to push everything to prod and making people work that way. But at least my experience has been that it also kind of sucks. And I think there's some better ways that we can do this. So, I think one of the reasons why dev, stage, and prod is such a painful kind of way to isolate work when it comes to data pipelines is just because data pipelines, data products, these are fundamentally different than building a SaaS offering or a service or a library, right? And the main thing is which is kind of obvious, is we have data and usually lots of it, right? So we have extremely long-running pipelines. Some of the pipelines that we have, and I'm sure others have, take hours and sometimes days to run. We also have, we're also having state that's really important, being both in the logical realm, which is code, configs, queries, as well as the data, right? So the actual data that's being stored. And so it adds a level of complexity because these are inherently stateful systems. And then often the data that we're talking about is extremely large, right? So it's, we're talking about terabytes of data, sometimes tens, hundreds of terabytes of data. So just trying to, deal with that and be able to isolate that is really non-trivial, at least in my experience. So I think we see data, kind of engineering teams trying to get work in an isolated way, but I think coming up against some really common impediments. So duplication, right? Hey, I want to try running this change that I'm making, and I want to see way down in the pipeline what impact this is having on the business, on our customers, et cetera. And so I end up having to copy a ton of data, all the data and intermediate data that I would need to be able to compute that in order to run that test, right? Or the other favorite is well, we could take some shortcuts. We'll read from production at a certain point, but then write to a different environment, right? There's the other one, which is hey, is anybody using the staging environment? When can I get access to that? I want to run some tests, and then great, you wait 3 days, and then all your colleagues have to wait a few days while you kind of run your tests. And then the worst thing is when you spend a lot of time running something through, testing it, and then realizing that what you thought you were testing was actually not what was actually there because someone updated the data, or you weren't quite reading the data from the right place. You got kind of step 13 in this whole process of setting this up wrong. So I guess like if we took a step back, right, and thought about like how would we really, really want this to work, right? Like just imagining like a great experience as a data engineer. Like to me, at least, that would be like, okay, every developer gets their own version of the data, their own version of the entire pipeline, right? And people can create these things like super quick, like within 5 minutes, right? Like I can be up and running and have my own version. I don't have to think about, like once I create that environment, I just need to know the name of it. And then all my tools are kind of like in the context of that environment. So I'm like kind of, it's almost as if I have my private production version that I can test on, right? The other thing is like, I don't want to write workflow code, right? Like, why should I? I mean, most of the transformations that we're doing, these are functions with inputs and outputs, right? I shouldn't have to be like writing logic to wire them together. And then usually I should be thinking about, well, how am I going to know if my test was actually good and is actually doing what I want it to do? What's the data set I need to produce with my change that I can measure? And as long as I can do these things, right, then I should be really productive. And if 15 or 20 or 25 people can all do these things in parallel, well, that seems like a recipe for getting a lot more done and people just being happier in general. So I think this kind of idea is what myself and kind of the folks at Dagster and things like that, we think about as this is like a pipeline sandbox, right? So this is like a fully functional and isolated version of the data pipeline where the logical state corresponds to like a Git branch, and the data is completely isolated. I think the cool thing, and this wasn't true like a few years ago, is like the technology for this like exists, and it's just really a matter of putting it together, at least in our experience. So like if you think about Databricks, like that is like a great compute environment, right? It does a lot of other things, but if you just think of it in that level, like great, I can do kind of stateless compute. I can run the same computation multiple times in different environments and get the same result. Dagster is like a workflow orchestration tool that we really love. I think, and one of the things is that kind of their cloud offering includes like native branching. So it's really easy to kind of create your own version of the pipeline for each developer, and track that back to a specific MR. And LakeFS, which I think also has a booth here today, and they're basically the metadata layer that makes it possible to spin up a branch of like terabytes of data like within a few seconds. And then GitLab, which is just like the kind of CI and version control tool that we happen to use, but there's nothing really special to that in terms of being able to do this. And so this is like kind of just this idea of having like a data sandbox. Like we have a production pipeline, maybe we have some other things for specific use cases, but each developer can kind of just create their own, kind of clone extremely quickly and cheaply. And the main thing is that this kind of concept of branching is stacked, and so you can go across these kind of technologies, and you basically have the same concept of a branch that goes throughout these. All right, so I'm going to try a demo. It's not going to go quite as I wanted to, so bear with me, just because the AV setup is a little different than what I was expecting, but I will give it a shot. And okay, so here's my code, right? This is actually like our production, our main branch for our data pipeline. And I was doing some kind of cool stuff where I was like, oh, maybe we could like kind of resolve business together, is like using some clustering with these embeddings that we created, kind of off the shelf stuff, just to see how that works, right? Well, now all of a sudden it's like, okay, Ryan, it's time to stop messing around. Customers complaining about this issue, and you really need to just change what you're doing. And I'm not going to get access to my terminal. All right, so just play along with me, right? I'm in my terminal. I am like saying, okay, cool. I'm going to go back to my main branch. I'm going to pull it down. I'm going to create like a new feature branch, right? And then I'm going to basically just make my little change, which in this case is to change one of our kind of strategies, and then I'm going to do a push. Okay, Sorry, just use your imagination that all that happened, but I'm sure everyone here has done that multiple times. Okay. So now what happens? Okay. So what's going to happen when I do that deployment is the CI is going to do a few things. The CI is going to say, oh, okay, cool. You just created a new MR, right? It is, whatever. I think I had MR like 1477 or something, right? Go tell Dagster, using your configuration on your MR, to go basically, here's the data sets, here's the transformations, go just build a pipeline for yourself, right? It's going to go tell LakeFS that, hey, my MR is coming off of branch, so I must want the branch data, or coming off of main, so I must want the main data. So go and create like a branch of our entire main pipeline, like all the data sets, which is like several tens of terabytes, and basically make that as available as a branch as well. And then go to the meta store and say, hey, create a new schema for this branch that basically points to these references to the data, which then allows me to then kind of have an SQL interface and the other tools that we like using for a meta store to access it. Okay, and so this generally takes about like 4 to 5 minutes to happen. Most of the time it's just instantiating the DAG, but it's pretty quick. And then what I can do is, so now, here I am like in Dagster. This is this is kind of the stage that I changed in my pipeline. I changed one of the resolution strategies, right? It tells me, what it is, that this is for branch, 1477. I can go to LakeFS and, here I am, I got like 1477. This is like kind of telling me all the changes that I made to this branch, right? And then if I, kind of run this computation, and it's going to take, I don't know, a few minutes, so we're not going to sit here and watch this spin, right? Then I can go into Databricks. And what's really nice about this is I can say, all right, well, this is the data set that I wanted to influence. And this could be like the actual data set that I changed, or it could be like 7, data sets downstream where I wanted to see the impact. But then I can very easily say, okay, well, let me look at this branch, on MR 177. Let me compare it with the same data set on main, right, which was what my branch point was from. And then let me see what happened, right? And so kind of as expected, well, I guess what we're seeing is that, okay, most things kind of are pretty much the same, except that this one here, and if I wanted to just kind of show that a little bit, could see that these are almost all identical, except this one kind of resolution strategy changed. We're resolving a lot fewer, like kind of in my candidate branch, which is in the target branch, which actually makes sense because I know I made this like less restrictive. But I think the power of this is that like you can kind of make changes really far upstream in a really complicated data pipeline, and be able to, as long as your stuff runs fast enough, right? That's a whole other thing. But like each individual developer can really run things end to end, and so when you're at the point of merging, you can put together a notebook like this, show people, being like, yeah, here's the impact of my change, and then be really confident when you actually merge that change in. We have like, 13 different work streams going at a given time, and this is like a data team of like 20 people. And so just the velocity that we're seeing is like way better. Also, like I always argue, at least to people who will listen, that, one of our biggest expenses is payroll, just at Enigma Technologies, right? One of those biggest expenses within payroll is like kind of our data team. If you can increase the productivity of that, it has lots of benefits just around, people are not thinking about this stuff around, oh, how do I actually test this stuff out, and actually thinking about the problems. People are going to become way more innovative and be kind of thinking at like higher level things that can actually affect the product and customers versus just how do I test my change, or how do I actually create an environment where I can do that. So I don't know if this is if there's a Q&A or anything like that, but that was what I wanted to talk to you all about today. So yeah. Thanks so much for coming. And Nick, thank you.